directory enabled cluster or integrated cluster, you no longer have to use that local admin user account. So this is just a nice security feature and something that's been in preview and we've talked about before. So really just making sure that you all know that that went GA. Another aspect, which I believe was in the release notes last time as well, is the AKS auto certificate rotation process. So that's also gone GA. So essentially, we obviously use certificates to authenticate a lot of our Kubernetes components that we're managing on your behalf. And typically you'll need to rotate those certificates for, security reasons, policy reasons. And so we'll basically automatically rotate the like non-certificate authority certificates for the control plane, like the agent nodes, things of that nature. And we've already enabled this on, I think, like a handful of regions, but should be rolling this out to the rest of the Azure regions where you have AKS by the end of, I think it's like February of this coming year. So that one GA, keep that in mind. And I think the only caveat here is that the cluster has to have a particular feature enabled around TLS. I can't remember the exact name, Dave. I'm not sure if you know. I think it's like TLS. Oh, it's TLS bootstrapping. I think that's what it is. So in order for AKS to be able to do this like automatic rotation process, you have to have TLS bootstrapping enabled. And there's some good articles out there on the Kubernetes docs that talk about how you can basically check and make sure that your Kubernetes cluster does have that enabled. And then last but not least, we talked about this feature as well, the AKS node image auto upgrade. And so that's now in GA. So if you want to opt in to have your node image or your cluster version auto upgraded, this is now a GA feature and no longer in preview. And then the last thing I wanted to highlight here, oh, perfect. I'm glad that you were able to pull that up, Dave. I think we're on the slide number. We're on 6. If you want to put it bigger too, just so that we can see, that'd be awesome. Dave, can you hear me? So we're on slide 6. We're up 1.
Slide 6. Okay.
Yeah.
There we go.
Then if you can just make it big so that we can see the whole slide instead of like the notes section, that'd be awesome. So wanted to call out the preview of Azure Key Vault Secret Provider for Arc-enabled clusters. So we've talked about the CSI driver move from a storage perspective, and with the integration of CSI driver and that being kind of the default storage driver, and then we created the or started to provide a preview for the extension for Azure Key Vault using the CSI driver. So that secrets extension, and that was an open source project for basically using that CSI driver to sync secrets from Azure Key Vault. So we're now providing this from an Arc perspective, which I actually think is really awesome. So if you have Arc-enabled clusters, right, whether those are on premises in another cloud provider, and you are making use of Azure Key Vault, you can now use this Arc-enabled extension in order to be able to securely access those using that CSI driver on whatever that Kubernetes cluster is. So I think this is awesome, especially for hybrid scenarios. So definitely recommend checking this out, playing around with it and seeing if it works for your use case, or just, I think, acknowledging the fact that we're definitely moving in a good direction with bringing some great features down to Arc-enabled clusters. So Dave, if you want to move to the next slide. I know this isn't super, like, it's not completely correlated with AKS, right? Like, it's not an AKS feature per se. But I do think this is a really exciting release. So if you didn't hear about this, we just went into preview with something called Azure Load Testing. And I will say this is something I know a lot of people on the GBB team have worked on recently, is figuring out ways they can help customers understand performance and honestly their application baseline, the needs, like how do we do load testing, especially as we have these applications that are growing. How do we understand where maybe we have some weak spots when it comes to handling load? And so we've created this service now to help you to do that without the need to kind of go out and provision a ton of infrastructure in order to do that. And then obviously we have these integrations with the various services on top of Azure. So you get really great insight through Azure Monitor into some of the performance impacts and implications of your workload scale as you're going through these tests. So it integrates with Container Insights, which I think is going to be super relevant, at least on the AKS side, to be able to kind of understand the container resource consumption and all that jazz. So highly recommend you check this out. We actually have it integrated into where you can do like CI/CD integration to basically say, hey, like if I have certain thresholds that aren't met, or if I have performance degradation or whatever that might be, based on your performance baseline from the Azure Load Test, then you can actually fail the build or fail the deployment. So I haven't played around with it. I think they just released it like literally 3 or 4 days ago. So highly recommend checking that out. And I know that our team's certainly going to try to put something together around, or excuse me, probably Dave's team is going to be putting some stuff together around how this works. So last but not least, I want to talk through a couple of ecosystem updates. So Dave, if you can slide over to slide 9, that'd be great. So one that I wanted to call out. So Richard Hooper has been like a huge advocate on these calls and is just super awesome and puts out great content. So I wanted to highlight, he has, I think, a newsletter that has a lot of these updates already kind of out there for you. And then he also does a lot of like mini videos and blog posts and things like that. So if you're not already following him on Twitter or following his newsletter, I highly recommend doing that subscription. So I'll drop the link in the chat here. Another one, this is coming up literally in 45 minutes. So if you aren't already signed up, we're doing a Tigera Microsoft workshop, which is basically going to be setting up Calico Cloud and some of their other features on AKS in order to get some observability from a network perspective. So if you're interested in network policy and want to get hands-on and haven't already had an opportunity to do that, you can actually go sign up right now. I just tested it. The link's still live. So that'll be happening right after this call. Another cool thing that I saw is that Aqua acquired Argon.io, and I had never heard of this particular company, but they basically work a lot in the supply chain security like software space. And so basically they're going to use this in order to enhance their kind of like code integrity, going through doing additional scanning and integration on code repositories, like build an artifact infrastructure, all of that kind of stuff. Especially kind of on the heels of some of these supply chain attacks that we've seen recently with like SolarWinds, for example. So from what I understand, based on the article that I read, they're basically going to bring this into their platform next year, but right now they'll continue to operate as separate entities. Wanted to highlight, so obviously we were supposed to have Phil from Open Service Mesh on the call last time, and unfortunately he had to cancel last minute. I believe he will be coming on a future show, but because of the backlog that we have currently, it might be a couple of months before that happens. So if you did want to check out kind of a more recent Open Service Mesh demo or walkthrough, he did one through the CNCF webinar series in October, like late October. So really this would have been probably very similar content to what you would have gotten. So I wanted to highlight that. And then last but not least, this little like ebook up here. So Tigera is actually providing access to the Kubernetes, like a brand new Kubernetes security and observability ebook. And I'll drop the link if you want to just download that and peruse it because it's free. And I feel like it's a topic that is super relevant to all of us right now and will continue to be moving forward. So that's all I had. I don't know if anyone wants to drop any additional thoughts, comments, updates in the chat. Oh yeah, I'll definitely drop the link to the Tigera workshop in the chat. Sorry, my brain isn't working. But I want to pass it over to our friends from Buoyant. I see Jason on video looking beautiful. So I'll pass it over to Jason and anyone else that might be on his team to introduce themselves. And then I'll let them have, the rest of the time today before maybe some questions and answers to talk about Linkerd.
Oh, awesome. Thanks so much. Hey, folks that are on the call, if you don't mind just putting something in the chat, I'd love to get a sense of how many of you are already familiar with what a service mesh is, and if you're familiar with Linkerd. And from there, if y'all are open to it, I'm going to share a couple slides, although I don't seem to have permissions. Is there any way that y'all could set me as the right account type here?
Yeah, I just made you a presenter, so it should come through.
Oh, there we go. Yeah, thank you, Darwin. So let me see if I can share the entire screen. There we go. All right, can y'all let me know if you see a slide deck?
Yeah, we can see it.
All right, awesome, thanks. So I'm gonna try and go really briefly through some slides, and then we'll just do this getting started demo. Does that sound all right for everybody? Hopefully. Okay, so let me just start with a little bit of little bit of what is Linkerd, right? So Linkerd is a service mesh, and if you don't know what that is, I'll talk about that in a second. We are lightweight, fast, and very secure. Been in production for a while. There's lots of folks using us, including a bunch of people over at Microsoft. You can find us on GitHub. We do weekly edge releases, and edge release is just kind of latest features rolled up. And then we do quarterly releases of major new features. If you're not tracking on it, we just released a Linkerd version that had policy 2.11 with back in November. So that was the first version of Linkerd that allows you to set application aware policy between your components. And then we graduated the CNCF this summer, right? So for those that don't know what that means, right, it means we've hit the highest standards of maturity for a CNCF project, according to the talk. It doesn't mean we're out of the CNCF. I can't see the participants. So if anyone has questions, I don't know, Kendall or Dave, do you mind interrupting me if something pops into the chat?
We'll do.
Thank you so much. So what does Linkerd do, or really what does any service mesh do, right? A service mesh is there to add some features into your Kubernetes environment or into your application environment. And it does it in kind of a different way than you might be used to, right? So instead of putting like additional libraries inside or functionality inside your individual applications, Linkerd adds things like observability, reliability, and security to your apps, but it does it in a way that shifts the responsibility from your dev teams and from the actual application code onto your platform teams, right? So we centralize certain things like adding metrics, setting some reliability things or doing MTLS, and you put it as a cross-cutting platform concern that your platform team can manage, right? So application developers can focus on writing business logic. Linkerd does this in a way that it's really focused on being really easy to use, and hopefully you'll see that during our demo today. I'm not going to talk about what makes Linkerd good. This is a public slide deck, so I'll share it out with y'all if you want to see it. But we're light. We write our data plane in Rust, right? So unlike most other service meshes you see in the market, we're not using Envoy. We're using the Linkerd 2 proxy that's written in Rust, and there's some really, really interesting stuff in Rust or with Rust. The main being that it compiles in a native code without any garbage collection, but it does it in a way that avoids a number of memory management vulnerabilities that you'll see in C or C++. We're very fast and low weight, so we ran these benchmarks. So we being the folks at Buoyant who make Linkerd ran benchmarks. So take it with an appropriate amount of salt. But the benchmarking suite that we ran that gave us these performance numbers is actually written by the folks over at Kinvoke, who got acquired by Microsoft earlier this year or maybe last year. But it's an open source benchmarking suite. You can run it on your own just to see like how does Linkerd compare to whatever other mesh that you're using. But we're very small and we're very fast. In general, right? Because I get this question a lot. Right. The answer is, when you ask how does Linkerd compare with Istio, or when customers ask me, should they use Linkerd or Istio, I answer, well, it depends on your use case, right? Like what features are you looking to implement? What amount of work are you interested to put into your service mesh, right? And for a lot of folks, if you're Kubernetes focused and you want things like security, observability, MTLS, some simple policy, then Linkerd may be the right answer for you. I hope that works so far. Let me see if I can pop out Teams for a second, see if there's anything in the chat. Right, the control plane is absolutely not written in Go. Raj, thank you for that question. So, the control plane is written in Go. The data plane is written in Rust, right? So Rust, or the reason you wouldn't write the data plane or the proxies in Go is because Go has garbage collection that goes on, which is great for memory management, but can be really problematic if you're running something that is really latency sensitive, like a proxy. For those that don't know, because I see Amuda's question, and I'm sorry if I said your name incorrectly there. A quick, like, what is a service mesh, right? So if you have something like an application here, right, and this is very close to the application we're going to be doing during the demo. We've got a web front end and two back end services, and they're all talking to each other. What a service mesh does, right, is essentially if you're in a Kubernetes cluster, right? So really our boundary here is a Kubernetes cluster. Let me center this a little bit. What we're going to do, and we'll do this in the demo. You install a control plane, and the control plane is like the interface between you, the platform operator, and the service mesh. And the control plane provides all that command and control that your proxies need to work. And then we modify our applications by adding a proxy container to every component, right? And this proxy will do things like handle mutual authentication and encryption. It will handle making routing decisions. It will handle, circuit breaking or whatever things you're going to put out in that space, or timeouts, or any other logic that you need there. And so essentially, service mesh is a bunch of proxies that sit between your applications and talk to each other, right? And then they can do intelligent things with your traffic based on that. And Paul, that's absolutely what we call a sidecar model, right? So we sit the proxy container beside your application, like the little sidecar on a motorcycle. So that's kind of where that comes from. Yeah, so if there aren't any other questions about kind of what is a service mesh, I'll go ahead and do a demo. Does that sound good? All right, I'm hoping that's a yes, and someone stop me if that's not good. All right, thank you, Muthu Kumar. Geez, I'm really sorry if I mispronounced your name there. So let me know if y'all can see my terminal and if things are sufficiently big. Yeah, Raj, I absolutely can. Do you mind holding that one to the end, because it's kind of a big one and I want to do the demo. And Paul, I'm going to answer your question as I actually do this demo. Is the screen big enough, or is the typing big enough? Let's hope so. So what you're going to see here, right now I'm running a local Kubernetes cluster on my Windows desktop using Docker Desktop. Currently I've got one application running. It's the emoji photo sample application. So if I port forward my service here, -n emoji photo. If I port forward my service, I've got a little application running. So I've got an app, right? And so I'm viewing the web front end. So I'm forwarding to the Kubernetes service that is the web front end. And it's talking to two other services that represent the various backends. There's one for voting and one for tracking which emojis should be on it. So I can go click on an emoji, view my leaderboard, see what the current state of the voting is in the environment, right? Then I can go back and vote on the favorite. So my application is in Kubernetes and it works, although it is slightly broken, and we'll get to that in a second. So what I want to do is, I'm going to turn off that port forward. What I want to do now is actually install Linkerd in my cluster and see what does it take to integrate Linkerd into my environment and then have my apps work with my service mesh. So for those of you that have used Istio, right, there's stuff you need to do, or I imagine Open Service Mesh, although I haven't used it, right? There's usually things you need to do to make it work with the mesh, and we're going to show you what you need to do to make it work with Linkerd. So first off, I'm just going to do the curl to bash install here. So I've already got it loaded here, but I'm going to say, it's 12:25 Eastern time. I'm going to say we're going to have a service mesh up and running by 12:30. But feel free to interrupt me as we go. I feel like we've got plenty of time. So I install sorry, did someone have a question? No, okay. I installed the Linkerd binary, right? So now I'm going to just update my path to add Linkerd to my path. We're going to check our current version, right? So you see I don't have anything up my sleeves, right? We've got the client version of 2.11.1, which is the latest stable release, and there's no server version because we haven't installed it on my kube cluster. And again, if you're looking at the getting started guide, I'm basically following through the steps there almost exactly. All right, so now I want to validate that I have permissions to install Linkerd in my environment and that my cluster is conformant, right? So if you're an AKS, right, do you have the right permissions to actually do the install? You know, Linkerd check -- pre will tell you. Same thing, it'll validate if I have permissions and if my cluster is set up correctly. So let's give that a shot and see where we go. So we get a bunch of checks, and it all ends up with, you know, our results are green check mark, so we're good, and we can actually do the install. So I want to show you what happens when we type the Linkerd install command. So what you're seeing is a ton of output, or a ton of YAML getting output to the terminal, but you don't see any new stuff happening over here on our cluster, right? That's because the Linkerd install command, it just generates a bunch of YAML, right? So it works off the same YAML templates as our Helm chart. And when you type Linkerd install, you can generate YAML. You could then, you know, save it into a Git repo, follow your GitOps flow to install it. And because the CLI and the Helm chart use the same templates, an argument that you can use for the Linkerd CLI also works on the Helm chart and vice versa. So there's not a lot of space between them. So if we actually want to do the install, in this case we do, we're just going to pipe it over to kubectl apply, and we're going to get Linkerd up and running. Right now I'm at 12:27, so I still think I have plenty of time here. Linkerd itself, what we did in 2.10 is we kind of broke it up and refactored it so that you could do the most minimal Linkerd install possible to kind of get your service mesh running, right? So what we have here is we're installing the Linkerd control plane. That is everything you need to do mutual TLS, to get statistics from the proxies, but there's no tools to collect them, right? So there's no data collection tool, there's no dashboard, any of that installed with the basic control plane, right? But the proxies are out there, and if you have a Prometheus instance, you can begin scraping those proxies and gathering the data into your metric store, or any other tool that can read, you know, that can scrape Prometheus endpoints. You can get this data. So I ran Linkerd check to just validate that my environment is healthy. And, you know, we see our status checks go green. It validates that our various pods are going. And then if we look here, we can see I've got the identity, proxy injector, and destination pods up and running in my environment. Any questions so far? Is this pretty simple and straightforward? Okay. Just to go back to our diagram for a second, right? What we've done here is we've got the control plane installed, but we don't have any proxies out there, you know, actually interrupting anything in the way our applications work, right? Or changing anything about our traffic. So Linkerd is installed, but we're not using it. So we're going to start using it. We're going to actually add our application, our emoji voto application to Linkerd. But before we do this, we're doing a demo, so we're going to want like a fancy dashboard. So I'm going to run, my little script decides to show me the Linkerd pods. I'm going to actually go ahead and install the dashboard component for Linkerd. So what this creates is, in a new namespace, it spins up a bunch of new components, right? The big ones are a Prometheus and Grafana instance, so that we can collect metrics and we can show them in Grafana anytime you want. This is really straightforward to externalize if you have your own Prometheus instance, and there's a lot of documentation on that, which I'm happy to share. We also get the tap injector and the tap service, right, or pods, right? So let me just talk about that. So one thing you can do with Linkerd, right, beyond getting a sense of, or, you know, beyond encrypting the traffic and getting new metrics, you can also use Linkerd to look at the metadata for each request between your applications, right? Which can be really neat, and which we're going to show in a demo. But that comes from this tap service. And when you install the Linkerd dashboard, we modify the mutating webhook for our applications so that it adds in the ability to do this tap thing. I hope that makes sense, but we'll see it more when we actually do the demo. We're just going to run the check command once again, validate that our install's healthy, right? We're good to go. We can get our pods. And then we can pop open a little dashboard, which I'm actually going to cancel out of because I don't feel like showing the dashboard right now. Darn it. Sorry, I accidentally canceled out of my script. So with this, right, I've got the Linkerd dashboard, I've got the control plane, but I don't have my app added, right? So let's actually do that. So I'm going to grab the deployments. Sorry, I don't usually type this. I have a script that does it all for me. We're going to get all the deployments and we're going to export them as YAML, right? And then what we're going to do is we're going to pipe them to the Linkerd CLI. We're going to tell Linkerd to modify them so they can join the mesh. So we're doing that second part where we add the proxy to these various components. Linkerd inject dash k apply dash f dash. All right, so let me run it and then I'll tell you what happened. So Linkerd inject, what it does is it just looks at the YAML file that comes through and it says, hey, is this a deployment set, a stateful set, or a daemon set? And if it is, it adds, I think it also looks for pods and replica sets. And if they are, it will add an annotation saying Linkerd inject :true, right? So basically just saying, hey, Linkerd mutating webhook, when you see this on a deployment, I want you to modify the pods so that they have a proxy. So if we look here, right, all of our voting web emoji services are being killed and restarted, and they go from 1 container per pod to 2 container per pods. And that's the sidecar. It's a sidecar thing, right? So we're restarting. Now let's look like that. The only transformation I've done to my environment is told Kubernetes or added an annotation to my deployments that say these pods should be injected with Linkerd. So let's see if my application still works as designed. Right. So I come in here, I check out Emoji Voto, and everything is running the way it was before. Right. I can view the leaderboard. I can vote on new applications. Right. The pods have been restarted, but I'm up and running. So I didn't need to make any changes. And the reason that is that Linkerd does not require you to use new custom resource definitions or new primitive types to make your application work, right? There's no virtual service or special gateway or anything like that, right? We use your Kubernetes objects. When we're looking for identity, we look at the Kubernetes identity assigned to a given pod. When we route between applications, we route to Kubernetes services that exist already in your environment. So the goal is, if you have something and it works today, we want you to be able to add that thing to Linkerd and have it still work, right? But somewhat better now that you've got Linkerd in place. And let's talk about what that somewhat better is. So we're going to pop out the dashboard. Do you have any questions so far? Does this make sense? And if you're following along, did this work? Yes, for each pod, you will add a proxy beside it. So sorry, that was Vinod asked. So for each app pod, 1 extra Linkerd container will be added. So it's not a new pod; it's a new container per pod, right? And a little bit of weird Kubernetes trivia, right? Like pod came about because we had Docker containers, and it was it's a little whale, and then a group of whales swimming together is a pod, right? So it's the containers that scale together, right? And that's our pod. And then Larry asks, is Linkerd inject used across the board or only for getting started scenarios? Yeah, Larry, great question. So Linkerd inject, all it's doing is adding an annotation to the YAML. So let's take a quick peek at what change it made. So hold on. Let's do k get deploy -n emoji. Let's call it web. So I'm just gonna go grab this. Yeah, thanks, Kendall. I don't actually know anything about Dapper, if I'm being honest. But there we go. This is what Linkerd inject did. Is it changed our YAML to add this annotation under the pod template, right? Add this annotation. That's all it is. You can put this annotation on a namespace, on an object, or even all the way down on an individual pod. And in general, like I don't know a ton of folks that are running Linkerd in production that use Linkerd inject to actually get stuff in, but there are definitely folks that do it. So let me run that dashboard again. I'm sorry, did someone have a comment or a question? Okay, nope, never mind. So this is the Linkerd dashboard, right? So to start, right, with Linkerd, we didn't, or with our application, I haven't done anything to emoji Voto to tell it to emit metrics, right? I haven't instrumented anything, but I'm able to see for every namespace in my cluster, I'm able to see how many pods are in the mesh, and of those that are in the mesh, right, like what is the overall success rate for that namespace or for that pod or for that workload? What's the saturation? So what are the requests per second coming through? And then latency by latency bucket. And also if I want, because of that built-in Prometheus and Grafana, I can pop out a Grafana dashboard at any point and just see, whatever queries I've set up in here. So that's our story. I can take everything. I can sort by success rate or any other criteria that I want and start digging in and finding stuff. So this right here is the Linkerd getting started guide, right? If you can pop through, look at the dashboard and add your application, like you've done what you need to do to start with Linkerd. There's a bit more I can show you because I'd love to just peek at a couple other features, but if you have questions, now's a great time to ask. Okay, well, I'll keep going, but please don't hesitate to interrupt me. So you can see here, right, what I've got now is this nice little service graph that tells me, what components do I have in this namespace and who's talking to what, right? Which is cool because before I didn't necessarily know, well, I knew because I've done this like a million times, but you don't necessarily know what the traffic pattern is in your environment. Well, in our case, it's very clear. We've got VoteBot talking to web and web talks to voting and emoji. Now, because my emoji vote service is broken, it looks like it's working, right? Like I can see here, right? Everything seems pretty reasonable. Like I can vote, view my leaderboard, right? It seems healthy, but when I look at the overall success rate, I see that I'm under 100%, which is weird, right? So looking at my deployments, once again, let's just sort by success rate. VoteBot and emoji are perfectly happy, but web and voting are not, right? So there's something wrong in this link. So let's just click on web, right? Because it's the first part of that path, and let's see what's going on. Well, I can see that requests coming from VoteBot are hitting an 89% success rate, so that sucks. Web is making requests that hit, whatever, a 92%. So what's going on? Well, because of this tap functionality, right? So the stuff I get with Linkerd Viz, I can now start seeing the individual, like not just the the overall details about my environment, but I can actually see the individual API calls that are being exercised, from what app to what app, and how many, what's the speed, what's the success rate, and then I can launch a live tap of traffic, right? So I can see pretty quickly that from this web service over to voting. I'm sorry, I'm hearing somebody on the background, and if there's a question, I'm really happy to help. Oh yeah, Raj, great question. So Raj asks if I can describe success rate. So what that means is was this particular request successful based on whatever criteria we're looking for? So for an HTTP request, that is, a status code other than 500, because a 500 represents a 500 represents a server failure, right? So everything other than a 500 from an HTTP request is a success according to Linkerd. And for gRPC, right? And you'll see this when we do the tap. But for a gRPC connection, we don't look just at the HTTP status code, which is going to be healthy, right? We look also at the gRPC status code and what it returns. So when we see a gRPC failure or an HTTP failure, that's when we represent something as a failure in a request. Yeah, no problem. Thanks for asking the question. So we see that, from web to the voting deployment, on this particular path in the API, we have a 0% success rate. So let's go in and tap some of it. So tap is capturing the live traffic, or more accurately, capturing the metadata about the live traffic, because Linkerd you won't actually see the request body, but you'll just see the metadata about the request. So what we're going to do is we're going to tap from, right. So we're tapping the web deployment, right? And we're looking for calls to voting on this basic path, right? So this basic path inside their API. So we're going to get some requests, and then we're going to stop it, right? So we see for every request, we had a status code, an HTTP status code of 200, because this is a gRPC connection, right? But Linkerd automatically understands gRPC and is able to pull out the gRPC status, which, by the way, an unknown is a specific gRPC error message of an unknown error type, right? So we're seeing an unknown error arise for calls when we hit this vote donut URL. And then we can actually pop over to voting, and we can see in a little bit more depth exactly what's happening. But essentially, we can just confirm that, when anything calls to this vote donut API, it fails. But when it calls to other APIs, it works great. So we can pop into our app, try voting for a donut, and we can see that we've got an error, right? So something's gone wrong, and it's to do with the voting. So here, I was able to use my service mesh to kind of track down the issue, view the individual API calls, and get a sense for exactly what went wrong in my environment. And the overall process of instrumenting this was pretty lightweight. For folks in or listening, if you could mention in the chat, can I get a thumbs up for anyone that went through the Getting Started guide? And then, are there any questions? Okay, Raj, do you want to bring back up your question from earlier? I think it was Raj. I'm sorry if I got the wrong person. Okay, this is another good one. Is the gRPC status for your control plane communication, or does the application? Oh yeah, that gRPC status is, so this is not control plane communication. This is Linkerd. That what we were seeing. Sorry, let me go back to it. What we're seeing right here when we do the tap, what we're seeing is the gRPC status code of the call from web to voting. Right. This is not a Linkerd error. This is an application error that we're citing in on. Right. That being said, Linkerd does use, like, the actual Linkerd control plane components are talking to each other over gRPC, or generally talking to each other over gRPC. I think it depends component to component, but most of the inter-app communication. Yeah. So thanks, Raj. Raj also asked about, like, the idea of, like, a common sidecar using, like, eBPF model. So this came about, there was if y'all have heard of Cilium, right? Like, they've been talking lately about the concept of how you can take network policy and a network service and use it to give you, like, application level details. And there's a great guide, Linkerd MTLS guide. There we go. So I'll put this in the chat. This talks about it in a little bit more depth, right? But essentially, right, having one sidecar per application moves that security boundary for things like policy or encryption or identity, right, from the node or wherever, right, from whatever point it is, to, like, the smallest unit of security in your environment, which is the individual pod, right? So it just depends where your boundary needs to be, and also, like, what features and functionality are you using, right? So I think Cilium is a great tool. I'm not, like, an expert at it, but it's a great tool. And things like, the idea of using, one proxy per node is something that a lot of folks did earlier on, like in Kubernetes. It's something that Linkerd did originally. I know there are other tools that tried that model, right? And then the move ended up being, instead of one per node, over to one per container, right? And one of the reasons we work on making Linkerd, like the Linkerd proxy, so small and so efficient is to minimize the cost of that resource tax that you get for running those individual proxies. So I'd say there are benefits to doing one per host, right? And that is fewer resources to use. And when you're using a more heavyweight proxy, like that's a bigger deal for sure. But there are also disadvantages, namely being, where is your security boundary and where is your trust boundary in any given environment? Yeah, well, I'm not arguing, right? Like everything's, there's lots of great tools and everyone's use case is different, right? But we happen to think Linkerd is fantastic, and I hope that you try it. Okay, any other questions? Anything y'all want to see? Got a Linkerd environment that we can poke at. The only thing I'd add beyond this, if no one has anything, is I can talk a little bit about Linkerd 2.11 and what happened with policy. So I think I've got 2.11 slide in here. Yeah, so I'd kick off, like, go through the Getting Started guide if you haven't done it. Oh yeah, I also want to plug the Slack. So go through the Getting Started guide and check that out if you're curious about Linkerd, right? Like, which, if you're here, hopefully you're curious about Linkerd. The other one is check out the Linkerd Slack. This is where you can, if you have questions and you didn't feel like asking them in this forum, you can pop into our Slack. Ask me directly. There's lots of actual maintainers and really strong technical folks on there as well, if you want to ask some deeper questions. And just get in touch with the community of users. It tends to be pretty friendly. Like, everyone's been nice to me there, right? And I've only been here, well, I guess I've been here 8 months now, so it's a while. But I would recommend it. And then as you start getting deeper, it's really nice to be able to have a line to reach out to people as you start running into stuff. Yeah, absolutely, Raj. So Raj asked if I can compare the architectural differences. So that's actually a great one to pop into. So for folks that have used Istio, right? Like it does a bunch of jobs, right? So it is an ingress, it is an API gateway, it is a service mesh, right? And it's doing all those jobs together. And if it works for your use case, it's doing them well, right? Linkerd focuses exclusively on east-west traffic inside the cluster. So that means Linkerd does not ship with an ingress, right? Like, it will work with whatever your ingress is, right? And like, I know there's that Azure application gateway thing, and I forget the name of it. And I'm sorry, Kendall or Dave, if you'd inject that in, I'd be super grateful. But you have examples of working.
You said Azure Application Gateway.
I think that's it. Is that right?
Yeah. Mm-hmm.
Yes. Okay. So things like that, right? You can just slip those in. Thanks everyone for for the answers. Yeah. So you can slip in whatever your tooling is for either API gateway or ingress, and it will just work with Linkerd pretty natively. The other thing is, let's do some CRDs. Okay, get CRD. So CRD is a custom resource definition. That's a new class of object in your cluster. Right, let's grab Linkerd. So you'll see there are 3, and there's actually 4, because the 4th is the traffic split one, which is an SMI spec feature, right? But there's 4 custom types included when you use Linkerd. And if you saw me today, I got my application working and I'm running everything without using a single custom resource definition from Linkerd, right? Linkerd works natively with your Kubernetes application with Kubernetes primitives. So we don't require you to do new stuff. So I get folks ask me a lot, like, well, why should I use Linkerd? Yeah, so let me answer you, Senk, in just a second. People ask me, should I use Linkerd? Should I use Istio? What am I doing? I'm like, well, start with what features do you want, right? Start with what features do you want, and then go from there. But the thing I'd say often is, if you start with Linkerd, your cost to migrate to something else is low, right? It is the cost of the initial adoption of your other service mesh, because Linkerd doesn't change the way your application works, right? So to add or remove something from Linkerd, you have to add an annotation or remove an annotation and restart the deployment, right? Which should be about zero cost for everyone, right? And if it's not, let's talk about liveness and readiness probes and how you should use those to make sure that your applications can stay available through a Kubernetes rollout. So that's the point, right? By staying Kubernetes native, we make it really low cost to use. That being said, as of Linkerd 2.11, we now have primitives in there so that you can set up policy between your applications, where you can say explicitly, what traffic will I allow to a given application? So it's server-side policy. So when you think of it, like in terms of emoji voto, right? If I made a policy for web, right, I would say on web, these are all the things that are allowed to talk to it, and only these things may talk to it. Only what you allow is put on. So it's allow list as opposed to deny list for policy in Linkerd. And then Sank, and Linkerd doesn't use Envoy, but they also don't have their own ingress, right? So we have our own sidecar proxy, and I saw Saba answered that already. So thank you so much, Saba. Any other questions? Or I guess, Raj, did that help you as far as the kind of architectural difference? Awesome. Okay, well, yeah, let me go back to slides then. Yeah, big one is in Linkerd 2.11. Yeah, Alice, I see tons of folks using multi-cluster and some really interesting use cases. So I'm sorry, I'll read Alice's question. Alice asks, are you seeing many people using multi-cluster in Linkerd? Absolutely, right? Absolutely. It's I wouldn't say super common, but a lot of our big production users are using multi-cluster. What inspired Linkerd logo? I don't know. I actually haven't been around long enough. I'll ask and I'll have the answer. I'll have the answer next time. It's kind of neat, right? But I have no idea where it comes from. Saba says that there's a product for managed Istio. Yeah, there's actually a bunch of them, right? So there's a lot of providers out there that are going to sell you things to make Istio easier to run, right? And that's cool if that's what you need. Yeah, and that's all that I have, I think.
Awesome. Thanks, Jason, so much for such a great overview and for kind of answering all these questions. And we really appreciate having you on. And I think this was really beneficial to everyone. And I think you did a great job. So thanks so much for the partnership that you showed here. And thanks everyone for, Singh just asked another question. I missed that part then. Do you have ingress controllers or not?
So Linkerd does not include an ingress, right? Like the ingress is going to be something that you'll provide externally. So there's lots of content out there about using Nginx or Ambassador, Edge Stack if you use Ambassador. But no, Linkerd does not have an ingress controller, right? It will work with whatever ingress you choose to use.
Okay, awesome. Thanks. And I'm glad that we clarified that in case anyone else missed it. But are there any other thoughts, questions before we close out today and give you, 5 minutes back? Once again, I think we have on the calendar already the Security Center session, so that'll be 2 weeks from now. And then most likely we'll break for the year and we'll come back with some good content and have some things lined up for 2022. So if anybody has any questions, we'll kind of pause here. And if not, then we'll let you go.
Yeah, well, thank you so much for having me. This was really nice.
Awesome. Of course, we'll have you back sometime soon, as updates come out and new things are introduced. Oh, there was another question that dropped. Is there a Terraform provider for Linkerd?
Yeah, so Linkerd, like Buoyant, doesn't support a Terraform operator, but there are a couple community Terraform providers out there, right? And then if you can use Terraform with Helm, right, there's a lot of folks that just use it that way. I hope that answers your question.
All right, awesome. Well, thanks for the final question there. And we will see y'all again in 2 weeks. Looking forward to it. Bye, Jason. Thanks again.
See you. Really, really appreciate your help.
Thanks a lot.